Hello everyone, welcome to Practical GCP. It's the end of 2022 and I thought the best way to wrap up the year would probably be revisit by going back to everything that happened in the Practical GCP channel in 2022 and then maybe give you a history to how this channel got started and why I created this in the first place. And going through all of the videos I've actually created in this channel one by one with a one-line description and a table of content, which is easy for you to kind of jump to the areas that you would be interested in very quickly, right? And without further ado, let's have a look at the bit of the history of this channel. So just kind of want to revisit a little bit when at January this year, when this channel got started. So when I started this channel, I didn't actually think too much, I would say. I have a lot of friends and colleagues in the past years been telling me, Richard, is there a way you can kind of share more publicly on the things you know? And then I've kind of wrote some articles, but didn't really write articles. And I kind of been struggling to find a way to share the things I know, but I do actually like to talk about things a lot, right? And so, but also at the same time, I thought many of you may have the same experience that if you created some solutions, right? And then after a few months, you kind of forgot about how you actually did it. You probably did this at work, right? And then the source code is probably not available in there for the other people to kind of make use of your solution and learn from it. And also for yourself, if you try to solve the problem again, a lot of the time you don't really have anything to go back to, and then you do forget about these things, right? And then, but if you actually created like a YouTube channel and record those, not only you can share that with everyone else, but for yourself, you can have a place to revisit. And so you can very easily kind of dig into any of these things that you've done before, including that's why I've been publishing source code as well, because that's the things that you can actually, go back and run those things. So it actually saves a lot of time in the future when solving the same kind of or similar kind of problems. But I guess one thing is very important. I thought, would it be cool to start something new and then going back at the very end of the year, maybe I've got 30, 40 videos. I didn't know whether others is going to like this channel, but to be honest, I didn't really mind too much. It's something I created. I just thought is very useful to have to put something down that as something like achievement I've done for myself. So when looking back, I can see all of these things I've done, and that is just making me very happy, right? Feeling very happy, I would say. So yeah, so I didn't actually think about anything about getting whether people are going to follow the channel, they're going to like you or not. But what actually happened was, you can see at the very beginning I had this kind of interstellar themed video, which I kind of explained a little bit why I started this, what this is for. I didn't actually have much ideas, much clues on what I'm going to create, right? It's just kind of crack on, do it. And then you can see one of my first videos here is pretty crappy, right? It's like a video quality is pretty poor. I'm not even sure you can actually read the text very clearly, and then with some backgrounds that doesn't have green screens. I didn't know how to do any of this stuff, but I think I was trying a lot to produce good content at the time as well. And then I kind of started getting the hang of it. But over the next couple of months, you can see this one is quite different with a much better quality. I've got my a microphone here. I've got you probably can't tell, I actually have a I have to actually have a green screen behind me, so which I can actually do the proper kind of blurry effect of the background in blending myself into the video, which you learn these kind of things over time. It just I know it's not like really about how professional the video is. I think it's pretty cool to learn these kind of things on the way as well. I think one of the really surprising thing was, I think back in October time, I got referred to be a member of the GDE program, which is a Google developer actually for the Google Cloud category. So I was like, I didn't even know what this thing was, and that was not some of the intentions I created video for. But because of the recognition, I think I was really happy and to be part of the this as a member of the GDE program, and able to see and learn from many other experts have direct contact with the Google product teams to give feedbacks, which was I think it was really useful to me and the community as well, right? That was a complete surprise, but it was I guess I felt really happy that I got recognition in this space as well because of the content I've produced. But I mean, this is complete surprise, right? So if you look at right at the very beginning in January, so I was only talking about like, I kind of like to measure, how many people kind of, whether people kind of find the others find the channel useful or not. So initially in January, I've got like 15 hours in a whole month of watch time. But 11 months later, where there was a peak in November, so that was actually a whole month. There's actually 188 hours of watch time. That was just incredible, right? Did not expect that at all, right? This is what happened, right? It's just, as of now, I've got, today, I've got 35 videos plus obviously the introduction into like a themed kind of video, but there's 35 videos I've actually created for the course of the year, and now there are 484 active subscribers, kind of a lot of you watching this video repeatedly. So I guess my point being, if you want to start something like this, or you want to share the things or you just want to do it for your own reasons, it doesn't really matter, right? So I think the key is if you find something you like, right? This is something I don't think I can keep this up if I don't like this. And also, without your support and keep me, giving this feedback, I've started getting a lot more feedback lately, especially, and then with the recognitions as well from the GDE. So these things all kept me going. But I think the key is, you're gonna have to, if you want to do something like this, I think it's really key you find something you like, and then you just have the motivation to keep doing it, and then without asking anything in return. I think that's probably the key bits for creating a channel like this, which I find, I guess, like really, really interesting. And then, I can see lots of you actually, I hope, have benefited from the video with all of these watch hours, and I can see from the stats. But I think I'll really try in 2023 to keep up again. I'll probably have some different channels and probably slightly different focus areas based on your feedbacks. And I think, yeah, it's quite amazing. So something completely unexpected, the whole of 2022, right? Okay, so let's have a look at what happened in the whole year. So I wouldn't keep this video very long, right? So but I think what is important is just to have a summary of everything that happened in the year. So you can see this is the list of the 35 videos. This is made available in the video descriptions. It's all the links, you can click on them, so you can easily click on them. If you see anything you're interested in, you want to revisit some of this, you can use this as a kind of table of contents. But in this video, I will also go through all of them, right? And then I actually try to group them into the right categories, so you can actually, have a quick look of this video specifically, where you can actually see the introduction of the all the different areas of what this video is about before you jump in, which can be quite helpful, right? Which can be quite helpful, I think. Right. So the GCP Service Introductions. These are some of the things I've created actually, only a few months ago, but I think I put them at the very beginning. I think it's useful, especially if a lot of you actually new to Google services. Probably start from here, right? So first of all, BigQuery. BigQuery is the flagship of Google Cloud, right? There's no doubt about it. Everyone comes to use Google Cloud in one way or the other. Whatever you do, you kind of have to come across BigQuery. So this is a introduction section of all of the fundamentals and key features that you probably want to know up front, right? Before you kind of dive into the details. It will give you a kind of good wrap-up start of before you use the BigQuery service. And Cloud Composer is something that you can run Airflow, both Airflow 1 and Airflow 2, but I think most people run Airflow 2 on it right now. So you can run Apache Airflow in the managed service. That's what Cloud Composer is, right? So this covers, what Cloud Composer is, the architecture at a high level, the security command line tools, Kubernetes execution, how you actually run a customized workload, and some of the security aspect with the native private IP clusters, CloudNet, how you get outbound access, and the difference between Composer 1 and Composer 2. So again, I would recommend have a quick look at this before you actually dive into it, especially if you're new to Cloud Composer. BigQuery, I put up a lot of videos in this area, and then I think it's because of the flagship product of Google Cloud, and I think there's so many things that you probably want to know and you probably should know, and then there you go. So delta tracking is one of the first things I've created in this year, which a lot of you actually fed back and said this is very useful. And because, you know, especially when you have a lot of the upstream systems where it's very difficult to define the deltas, but you can actually get a lot of the data in first, right? So this is kind of using a hashing way to actually compare of the data, right? To compare the difference of the previous version of your current version, and then using something called the DML merge to actually identify the deltas. Now you can push it into your downstream systems, which can be, you know, within Google Cloud or outside. Partitioning strategy for BigQuery. There's a number of ways you can partition in BigQuery, and then there's also the time-based partitioning and the integer-based partitioning. So this has a very detailed breakdown of, you know, when you should use the time-based time unit column, the ingestion time-based or the integer-based. So I think it's a very good high-level overview, and also some dive into some of the details of the partitioning strategy when you should use one or the other when using BigQuery, right? And analytical functions and row numbers. So this analytical functions is one of the key things, also called window functions in BigQuery, which you can actually do a lot of powerful things, such as deduplicating data. So row number is one of the most powerful and the simplest ones that you can use a window function, a window, to actually find the duplicates and then rank to get the duplicates to correctly identified and removed. So very powerful thing. So have a look. This should be very useful, especially if you actually, if you're a data engineer. This is probably one of the things you're going to be using the most on BigQuery. Atomic operations is one of the very important things that you need to understand when using BigQuery. You can potentially, truncate a table and then load the data into the table, but you have to consider your downstream stakeholders, right? So if your downstream holders see an empty table, that's not great, because they have to somehow rely on checking if the table is actually empty or not, right? So that's very important, and you want to make sure you don't have this kind of problems. And so the atomic operations, there's a number of them, such as atomic write and atomic merge. So those are all atomic operations which you can look at the video, and it gives you a lot more details of how to use it correctly and how to make sure you avoid truncating the entire data table, which can affect downstream stakeholders. The cost always becomes an important thing when designing workload with BigQuery. So in the cost optimization video, I've actually included a lot of the details on how and different ways and the trade-offs between the on-demand pricing and flat rate pricing, right? So, and then there's also flat rate pricing, where you can actually have the 6-second billing to keep some of the repetitive but kind of specific time period focused workload. You can use those. You can use all of them combined as well, or you can just prefer to use the flat rate. It's a bit easier for you. This video has described all of the different scenarios and then how you would actually use different strategies to optimize your cost. So there's a function in the window functions in BigQuery called lead, which you can use it for doing very interesting things to fill gap in the data. You can see the example in here, which tells you how you actually can do that. But if you go to the video itself, it has lots of examples, source code, sample queries to show you how this actually works in much more detail. So I think if you actually, I think most people would actually face similar kind of issues when you have data coming in, you have gaps, right? How you can fill the gaps to make sure your data model doesn't actually have this gap, which give you a dip when you're actually looking at the stuff. So, and this can become very handy. BI engine, something has gone GA for a while now. This is one of the things that you can open up many different possibilities and improve performance of your BigQuery depending on your downstream consumption. So one of the key things can be you can be dashboards such as Data Studio or Looker, which now is called the all kind of merge into Looker itself as one product. But you can also have the Google Sheet and customer apps, which are basically directly consuming from the BigQuery API via the BI engine, which is basically just the in-memory cache layer, and that would give you something that quite significant improvements, especially for small and medium-sized queries that is repetitive for a lot of your workload. Fetch queries for Cloud SQL is a way that you can actually query Cloud SQL, right, on Cloud SQL without moving data, right? So it's basically a real-time direct access to the Cloud SQL. But obviously there's pros and cons to these things. Watch the video and it will tell you a lot more about this thing. But it is one of the things as an alternative to data ingestion, which is table federation in this case, what it's called, right? And then that is something in the video I've told you a lot more about what you can do with this federated queries with Cloud SQL. BigQuery Storage Read API is a very different API compared to the default SDK, which you probably run a lot of aggregations and you don't pull a lot of data out of BigQuery. The Storage Read API is designed for complete the opposite, which is something you make use of protobuf to allow you, there are some limits, right? You can look at the videos for more details, but you can pull a large amount of data into downstream frameworks such as Apache Beam, Apache Spark, or other direct integration, even within Jupyter notebooks. But it's more designed to have a little bit of filtering, but no aggregations, and then your downstream system can actually deal with all of that difficult stuff to basically move large amount of data around. So that is something that Google provided for you to get data out of BigQuery storage in a very efficient way. Okay, the next section is around Cloud Datastore. Cloud Datastore is very powerful document store, right? That is, you can use it for fast write and fast read in real time in a very efficient way when it's used when it's optimized correctly. So the first video I've created on Datastore is very, very important, which is around the key and index designs and how you would actually use it. The details you can look at the videos, but in a nutshell, is basically if you don't just use sequential numbers or dates for those things that use the index or keys, you'd hit something like a hotspot, right? So because Datastore is behind the scenes, is basically sharded into a different part of the disk when it actually runs the system. So there are certain techniques that you have to make sure your data is distributed into different storage backend, right? So then it doesn't create these hotspots to you. And then the very simple way to do that is, as you can see on the right hand side in this diagram, using a hash and then pre-appended to your actual value. So I've also talked about why I've been doing this, because of the potential of collisions of the hash, right? So, but have a look at the video. It has a lot more details in here for you to understand how to do key designs to make sure your system is fully scalable when using Datastore. A recent feature has been added on the Cloud Datastore, which is the TTL. It stands for time to live. I've actually gone through a number of scenarios and how you can use the TTL feature to, for example, making your data automatically expire to sync with your source systems. But it's a quite new thing. There's still a number of things I would say I wouldn't like that very much. So have a look at the video so you can see whether it's a good time for you to start using it or maybe not. Right. The system design section has a lot of contents. So this is basically something I've been focusing on with a lot of effort on try to share my experience on how to design different systems in different scenarios, right? This is basically the architecture section. The first one I've actually sketched out the first time, which kind of worked okay, but it's okay. To talk about the difference between ETL and ELT and how to build a transient data warehouse. So this actually illustrated some of the kind of concept of the common designs and pitfalls and why you probably don't want to do ETL and instead of doing ELT, and to use tools like such as DBT to build something called the transient data warehouse. The reason I call that is because it is usually a nightmare to try to end up with a data warehouse that you don't actually know where the data is coming from. So this is actually showing as a way to how you can actually have a full data lineage to rebuild your entire data warehouse from the data lake from scratch, right? This is some concept I've shared in this session. Could be quite interesting. Have a look if you're interested. So this is a ingestion topic about scheduling base, which is probably one of the most common things that you have for all of the data engineering teams, where you would use Airflow runs on Cloud Composer to get data from different sources, which could be FTP servers, APIs, databases. But this is just one of the designs that you can follow and including some of the recommendations on naming conventions. So a lot of interesting stuff actually being covered in this video, but also I've actually put some of the things in there because this was a video back from many months ago. So Datastream is actually a product in GA and a lot more powerful compared to what it was before. So if you have the relational database service, instead of just looking at the scheduling based batch ingestion, you can also look at some of the Google built-in products such as Datastream to how to get the event logs right in near real time back into your targets such as BigQuery. So the event-based batch ingestion is a very different way to think about the ingestion problem. So typically you have data coming in, and then it can trigger certain kind of events when it's kind of gets landed into cloud storage, right? So that events can be put into PubSub and get utilized, such as using a cloud function to then load the data into BigQuery from cloud storage based on some triggers. So this describes a lot more details on how you would actually do that, how you would design such a thing. And then if you're interested, have another look. I think this would cover one of the use cases and how you might have, especially when you don't know about some of the data, especially when there's manual intervention involved from the upstream systems, this can become very handy. So dbt workload. dbt is something I talked a lot, and then especially how to run it and where you can run it. So in this particular case, I've talked about how to use dbt with Cloud Composer 2 via the Kubernetes pod operator. And then you probably want to ask me, why don't you just run it directly, install a Python package on Cloud Composer? Okay, so typically you have Cloud Composer that is also have shared workload with other things. So, and then you may even need to manage the version of dbt of the two versions coexist, and then they might have conflict. So by using the Kubernetes pod operator, it's your way to use containers to completely decouple where this dbt job runs, right? So all of your installations of the packages, the dependencies is all done separately and packaged in this bit, right? And then you can actually push it to container registry, which gets pulled when you actually run your schedules. So this talks a lot more in detail on how you can actually do that. So another way to run dbt jobs is this still uses Composer, but one of the key differences, the previous one is using the Kubernetes executor within the Composer 2 cluster, which is on Kubernetes on GKE Autopilot. But this one is a decoupled way, if you prefer, and in my opinion, is probably a lot more powerful, especially for the decentralized workload, and especially for local testing effort as well. When you want to run this thing end-to-end on your laptop, it is actually much better to use the cloud batch service, which you can run this completely independently. You don't even need to have the cluster to run this job end-to-end, which you just need to plug into the operators, right? And then that can be any operator, such as the Python operator, which you can run the end-to-end. It is still quite a new service, the batch service. There are some pros and cons. The videos will tell you a lot more about it, so you can make your choice to see which one works better for you. The PubSub message consuming on the GKE Autopilot is one of the alternatives to, instead of, if you look at here, one of the ways you can actually get messages consumed on the Google service is to use Cloud Run. However, there's issues where such as the concurrency, the rate limiting if you have downstream system with third-party systems. So, and that's the push-based message consumer. So in this topic, I actually describe the difference and why you would want to use the pull-based message consumer, which runs on the Kubernetes cluster, and then how you can actually utilize things like batching as well, and then reuse the same HTTP connection when you have third-party systems to give you much better control of the message workflows and then volumes into downstream systems to make sure it doesn't crash them. So one of the very important thing, and actually very interesting thing that I learned from one of the Google product managers, is actually some techniques called the balloon pod. And then this video shows you exactly, including the source code and how to run, how to deploy balloon pods in a GKE Autopilot cluster to make sure, rather than waiting for maybe 1 or even 5 minutes for your resource to become available when you need to scale up. And this one instead gives you in seconds, because the balloon pause, if you look at here, is actually pending and then doing nothing, and then in the meantime, but kind of get ready and prepared for you to take the workload away from these balloon pause, basically literally doing nothing, just pending or waiting, right? And then behind the scenes over the next 5 minutes, in this one it says 61 seconds, but I think in reality it's actually a lot longer than that. The capacity can be added to refill the balloon pause, which can give you more background capacity that is made available for you to take away immediately for your critical services. Very interesting stuff. Have a look. So the Kafka topic in here is actually one of the very complex ones. It probably took me like 2 days to get this thing finished. But I think it's a very important way and a very important way to actually get data from a on-prem, especially if I have on-prem services, but without actually try to go backwards from the cloud. So you can actually, in this case, deploy a Kafka relayer. That's what I call it, because it's responsible for relaying messages by consuming from the source Kafka service and then push it into PubSub, which can then connect you to the rest of the Google services, such as the Pub subscribers for different use cases, and data flow to send data into BigQuery at scale in parallel, right? So this one I've also described how Kafka works in a nutshell, and the things you need to to look after. And then there's also a fully working version of the source code open source to you, which you can use as well. I think it's very interesting. It's a quite advanced topic, but if you like to see this thing, have a look. So BigQuery's scalable and cost-effective backup solution. So you must do a backup for BigQuery for all of the things asset you have. That is important, because in BigQuery by design, if you delete a data set, that is not recoverable, and you cannot use time travel for that. So this video tells you a lot more details about how you can actually utilize the events that gets generated from the cloud scheduler by looking at things have changed, and then to generate those events, which then you can use Cloud Function to trigger the backup jobs, or in parallel. Just keep an eye on the quotas so you don't overwhelm the quotas of when you're actually doing the snapshots, which is the key thing that you would use for the backup solution. Very often you actually get data coming into, let's say, the JSON line files or Avro files, or sometimes, in the same folder, and then, you can't actually split it easily because they're actually mixed with different kind of schemas. So in this particular case, this video kind of talked about solution, how you can use data flow to read multiple schemas, right, exist in the same sort of kind of, let's say, in the same folder with a mixture of different kind of JSON line files, and how you to split it via a pattern matching mechanism, and then split them then into different kind of partitions, and to eventually send them into BigQuery tables, right? So allow you to have dedicated schema for each one of those to have a much cleaner data lake on the right hand side when they land in BigQuery. So the PubSub BigQuery subscription is a relatively new thing, and it's a very powerful way to bypass the traditional way of using Cloud Data Flow to deploy all of that stuff, or the templating stuff, to get events from PubSub into BigQuery. So this is basically a shortcut of this service. And then followed by that, I've actually created a video showcasing a super lightweight real-time ingestion design by utilizing this particular feature, which now has gone GA for a couple of months. So this design is based on a semi-structured data, which doesn't care about the data schema. So be very careful when you use this and what kind of thing you use it with. But it is a very powerful and a super lightweight thing that you can use to directly get any sort of events in a semi-structured data structure into a single BigQuery downstream table that you don't really have to worry about, almost kind of zero infrastructure setup. So it's a very interesting video. I think this is probably the one I've got most people kind of viewing it because of the simplicity of the design. So yeah, have a look if you're interested in. So as you all know, like, in order to consume data from BigQuery, you don't often have many options rather than just putting a schedule in there and then query the table. So this is a BigQuery consumer that I've created the design based on the two information schema views that would give you a lot of information about when a BigQuery table has been changed, right? So that information is very valuable because you can track the changes in there and then send the proper events in the unified schema for your downstream services to consume. So now, rather than using the schedule to kind of crawl to see when something has changed, you can create a centralized service in this event message queue to then trigger downstream services when it's applicable, rather than trying to keep querying the BigQuery tables to see have the table change, right? So that is quite ineffective compared to this solution. Have a look if you're interested. So handle late arriving data is one of the very common things, I would say, because you may have different upstream systems, and some of these are quite old systems that they might not actually give you the data until a later hour or even a later date. So this is about this is the first time I actually explored the workflow service of Google Cloud. It has one of the key features in here, which is waiting until that something has happened, right? So this wait I think it can go up to a year, right? So this is very powerful that you can decide how long you want to wait for something to become available. So instead of saying, oh, I don't have this customer yet, I'm going to drop this request, you can say, I'm going to wait for a period of time. And then when the customer arrives, maybe in the next few hours, that's tolerable, right? And then you can trigger your downstream system and then complete, such as placing an order. So right, the next section is the CI/CD. So I've only have one video for this one, but it's actually quite useful one to showcase how to use Cloud Build. So instead of using something that is, just in GitLab or GitHub or something like Jenkins, you can actually utilize the Cloud Build services within Google Cloud to do the whole thing end to end. All you needed is a trigger, and then the rest I've explained a lot more details in how you can actually build it, tag it, and push it into artifact registry, and then deploy it to Cloud Run. You can do all of that in Cloud Build. Logging and monitoring, there's actually a number of interesting things happening in there. One is, in order to run operations properly, one of the key things you want to know is if a deployment has actually happened. By using the audit logs in Google Cloud, you can actually build some dashboard like this to see if a service that you own has actually had a deployment, right? So if you have a P2 or P1 incident, and when that happens, and one of the first things you want to check is has someone actually made a deployment. So rather than trying to crawl the logs when something has happened, why don't you have a dashboard and telling you exactly when something has happened? Now you can actually see the correlation between a deployment and the incident, which can be a lot of times the cause of the problem. The SQL way of querying logs is called log analytics inside the logging interface is actually very powerful. This thing is, I believe, is still in beta, but as you can see, not only you can use SQL to query the logs, which is semi-structured JSON data, right? Behind the scenes, it actually uses the BigQuery engine, but you can also visualize what you actually see. This is super powerful because, as you can see, if you log, every single request from the users, now you can actually see, you can build a real-time dashboard to see what is actually going on based on your logs. This is super easy to do some exploration and checking and debugging. It is all there for you, right? Security. So the Cloud IAP service is something I spent a number of videos talking about because it's one of the key things that you can access Google services without needing any public IPs or kind of this public whitelisting. It all goes via private, which is the Google via this IAP proxy, right? So this thing tells you a lot more in details how you can actually tunnel in via the IAP to access different kind of services in Google Cloud. It's a very powerful feature for private Google access that is not giving, is really kind of reducing the risk of exposing things into public. If you don't have public IP and everything goes private, and that is by default protecting you from all of these attacks where you have any public endpoint that's going to cause problems. If you have all sorts of users can actually do that with IP whitelisting, is just a nightmare, right? So have a look into this. I think is one of the key things of all of the videos on security to make sure we can do the fun stuff to make sure the security from the very basics is covered. And service account impersonation is so important, and also since Airflow 2, this is by default on all the Google Cloud connectors that you can use as well. In a nutshell, what it means is, well, least privilege, right? So you don't want to just have a massive service account that has all of these permissions, right? So what you want to do instead is you want to be able to impersonate as another service account. So there's two use cases to talk about. One is as a user, the other is as a service. So both you can follow the same pattern of the shared service account doesn't actually have a lot of permissions, but these can actually impersonate as other specific server account that which subsequently give you access to specific Google services or even to specific data set such as on BigQuery. So this is a very, very important thing that I really recommend you have a look at this video, and you should implement something like this in your organization to make sure you always have not one step to get access to data, but couple of steps to have access to get data. So this is super important from a security perspective. And the other thing about where you can do with the IAP is when you use App Engine with IAP, you can actually, instead of using some customized software or using your application layer to handle the authentication authorization, you can actually just use IAP to handle that. So because IAP behind the scenes is linked to users, which links to your Google Workspace account, which if you have Okta is linked to that altogether as well. So as a user, you can just simply use the IAP service to, for example, access App Engine in this particular case, which gives you private access without all of this public endpoints. So you can actually restrict your ingress rules to these services, and then that would give you a lot powerful way to, especially this is, I think in my opinion, mostly useful for internal applications in your organization to have access to build customer apps that is just for within the organization users. So that would give you a lot of protection out of the box by using the IAP services with App Engine. Data privacy. So I've explored the DLP service, the automatic DLP service for BigQuery back a while ago, where I would say is a bit of a hit and miss in terms of the accuracy of the detection results. But I think this thing, I think since then there is kind of the data catalog has been kind of merged with a number of other services. Now it's called Dataplex. I think Google is putting a lot more effort, and then the DLP service with automatic detection, I think it's going to be branded into that as well. In the sense of, I think I'm really hoping that the DLP, the Google service can actually make it a lot more easy to use rather than you have to kind of customize everything. The more this can actually be done automatically, the less ad hoc work that we need to do as engineers, because this is actually quite complex. I think Google in this case, I think in the next 2023, I'm really hoping they would have much powerful detections with automatic DLP to help us to detect sensitive data. Last not the least, leadership. So it's a random video I've created, but not complete randomness. I think I've talked about the difference between leadership and management, and why technical expertise is really important in today's technical world, in terms of how you can actually manage and lead a team with your own expertise, that you always brush up your own expertise no matter what your job title is. I think that is really, really important, and it's a key to drive the success of your team. With the management and the help from the leadership to lead, for example, lead by example as one of the most important things. I think it really is the key to build a successful team. At the last, what I really want to say is I want to thank you all for your support throughout the year. I mean, I couldn't believe where I got to after 11-12 months, and how many people actually how many of you actually watched my videos and give me the support and give me comments and feedbacks and asking questions. Please keep doing that. I mean, I think that initially, I think when I created this thing, it was more of like I'll just give it a try to see what happens. But now I think now I can see this does benefit a lot of people in the community, so I'll keep doing that. And then with your support, I think that gives me a lot more motivation to keep doing this, which I think is I'm really delighted for all of this support I've been getting in 2022. So it's the end of the year. It's a few hours until the new year. all I can say is let's celebrate. Happy New Year.
Go.